In this episode, we shift from the idea of preventing accidental exposure to the idea of reducing data exfiltration risk, which is what happens when an attacker or an unauthorized insider successfully pulls data out of your environment. Exfiltration is different from a public leak because it can occur even when storage is not publicly accessible, and it can happen quietly through legitimate-looking access paths. The hard part is that the same actions that make storage useful, like reading objects, listing directories, copying files, and syncing data, are also the actions an attacker will use once they have credentials or access. That is why detection-minded controls matter, because they are designed with the assumption that prevention alone will not be perfect. Detection-minded does not mean you give up on strong permissions. It means you build a system where abnormal access becomes visible and actionable before a small compromise turns into a large loss. The goal here is to teach you how to think about storage access in a way that naturally supports detection and response, even when you are not focused on specific tools or configurations. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Start by understanding the threat model in plain terms. For exfiltration to happen, someone needs a path to read data and a path to move it out. The path to read data usually comes from stolen credentials, overly broad permissions, compromised applications, or misused sharing mechanisms. The path to move data out can be as simple as downloading files, syncing a large number of objects, copying data into another location the attacker controls, or using an application workflow that exports data. The key concept is that exfiltration often uses allowed features, which means you cannot rely on blocking one obvious malicious command or one suspicious network connection. Instead, you need to notice patterns like unusual volume, unusual timing, unusual sources, or unusual combinations of actions. Detection-minded controls focus on those patterns because patterns are what change when the actor is malicious, even if the individual request looks normal. For a beginner, this is an important mindset shift. You are not only securing the door, you are also watching how the door is used. One of the strongest detection-minded ideas is to create clear expectations for normal storage behavior, because detection is about comparing what is happening to what should happen. If you do not know what normal looks like, then everything looks normal, including an attacker quietly pulling data night after night. Normal behavior includes which identities access storage, from which networks or locations, at what times, and at what rates. It also includes what kinds of actions are typical, such as reading a small set of objects repeatedly for an application, writing logs in a steady stream, or uploading artifacts during a deployment window. Exfiltration often breaks these norms by creating spikes, new sources, odd schedules, or broad reads across many datasets. Detection-minded controls encourage you to reduce variability where you can, because predictable access is easier to monitor than chaotic access. That predictability is not about making life rigid. It is about making real anomalies stand out instead of blending into noise. A practical way to reduce exfiltration risk is to limit the number of places data can exit through, which is sometimes called controlling egress paths in a general sense. Even without network details, you can apply this idea at the storage layer by making sure that most access happens through known applications and known identities rather than through ad hoc direct downloads. When everyone accesses storage in their own unique way, it becomes harder to tell which access is suspicious. When access is centralized through a smaller number of controlled paths, you can apply stronger monitoring and stronger checks at those choke points. This might mean encouraging users to retrieve data through an internal portal rather than directly, or ensuring that automated jobs use dedicated identities instead of shared credentials. It also means discouraging patterns like copying sensitive data into personal spaces or unmanaged storage locations for convenience. The more exit paths you allow, the more opportunities an attacker has to blend in, and the more places you must watch. Another detection-minded control is to design for high-quality logging, because logs are what turns storage activity into evidence you can analyze. Logging discipline is not only about turning logging on. It is about making sure logs include the information you need, are retained long enough to investigate, and are trustworthy enough to rely on. For storage exfiltration, the most useful signals include who accessed data, what action they performed, which objects or containers were involved, where the request came from, and whether the request succeeded or failed. Failed access attempts matter because they can show probing and trial and error, which often happens early in an intrusion. Successful access matters because it shows what data might have been exposed, and it can reveal patterns like an identity reading far more than it usually does. Detection-minded controls treat logging as part of the security design, not as an optional add-on after something goes wrong. For beginners, the key takeaway is that if storage access is not logged well, you may not even know you have been robbed. Once you have good logs, the next step is to think in terms of anomalies, which are meaningful deviations from expected behavior. Storage anomalies can be volume-based, such as a sudden surge in data reads or a large number of objects accessed in a short time. They can be scope-based, such as an identity accessing data in a boundary it has never touched before, or reading across many projects rather than staying within one. They can be time-based, such as heavy access at unusual hours compared to normal operations. They can also be source-based, such as access coming from a new geographic region, a new network segment, or a new device type. What makes anomalies tricky is that legitimate events can look anomalous too, like a one-time migration or a big investigation. Detection-minded controls do not assume every anomaly is an incident. They treat anomalies as prompts for validation, and they build context so you can tell a planned event from a suspicious one. The better your boundaries and roles are, the easier it is to attach context to anomalies. A major contributor to exfiltration risk is overly broad read access, because read access is the permission that directly enables data theft. Many environments are careful with write and delete, but surprisingly casual with read, especially for internal users, because reading feels harmless. In reality, if an attacker steals a user's credentials and that user has broad read access, exfiltration becomes easy. Detection-minded controls reduce this risk by narrowing read scope through least privilege and by layering monitoring on top of read-heavy roles. For example, if a role legitimately reads many objects, you might watch for unusual destinations or unusual timing rather than raw volume. If a role typically reads a small set of objects, then reading across an entire dataset is a stronger anomaly. The key is that permission design and detection design work together because permissions create the baselines that detection can evaluate. When permissions are sloppy, detection gets harder because there is no clear expectation. Another useful concept is data value concentration, which means some storage locations are simply more attractive to attackers because they contain the most sensitive or the most broadly useful data. Examples include exports of customer data, backups, analytics datasets, and shared repositories that aggregate information from many systems. Detection-minded controls often apply stronger monitoring to these high-value locations because the risk is higher and the impact of exfiltration is larger. Beginners sometimes think equal protection everywhere is the goal, but in practice, risk-based thinking matters because resources are limited and attention is limited. If you apply the same alerting sensitivity everywhere, you either drown in noise or you miss the real attacks. Instead, you decide where you cannot afford to be blind, and you make sure those areas have the strongest visibility and the tightest access. Tight boundaries make it easier to identify these crown jewel zones because they can be separated and labeled by purpose rather than hidden inside general storage. Detection-minded controls also include the idea of canary signals, which are deliberate indicators designed to create an alert if someone is accessing data they should not. You can think of this as placing something that is not normally touched, and if it is touched, that touch is meaningful. In a storage context, this might be a file or object that should never be accessed by normal workflows, so any access suggests exploration. The strength of this idea is that it reduces false alarms, because normal activity should not trip it. The weakness is that it must be managed carefully so it does not become a trap for legitimate users, and so it does not create confusion in audits or operations. The beginner lesson is not the specific mechanism, but the principle. Good detection includes signals that are both reliable and hard for attackers to avoid. When you design storage so that sensitive areas have clear separation, it becomes easier to create reliable tripwires that actually mean something. Another angle is to reduce the attacker's ability to stage and package data for theft, because exfiltration often involves preparing data before moving it out. An attacker might copy many small files into one place, compress them, or generate an export that makes retrieval faster. Even if you are not thinking about commands, you can still think about storage behaviors that support staging, like creating new large objects, copying across boundaries, or enumerating many objects to select targets. Detection-minded controls watch for these multi-step patterns, because a single read might be normal, but a sequence of enumerate, copy, and bulk read is more suspicious. This is where correlation matters, meaning you look for related events across time rather than reacting to one event in isolation. For beginners, correlation can sound advanced, but the core idea is simple. Attackers follow a process, and that process leaves a trail. If your controls are designed to notice the trail, you can intervene earlier. Response considerations are part of detection-minded thinking, because detection is only valuable if it leads to action that limits damage. In storage exfiltration scenarios, the earliest useful actions often involve confirming whether the activity is legitimate, narrowing access quickly if it is not, and preserving evidence so you can understand what happened. This is why identity design matters, because if you can disable or rotate a compromised identity without breaking everything, you can contain the incident faster. It is also why boundaries matter, because if access is scoped, you can lock down one boundary without shutting down the entire organization. Beginners sometimes imagine response as a dramatic all-or-nothing shutdown, but in real life you want precise controls that let you isolate what is affected. Detection-minded controls encourage you to build that precision ahead of time, rather than discovering during an incident that you have no safe way to cut off access without causing chaos. Even without tools, you can understand the goal: reduce uncertainty fast and reduce exposure fast. When you tie these ideas together, reducing storage exfiltration risk becomes a balance of prevention, visibility, and purposeful design. Least privilege and tight data boundaries reduce how much any one identity can access, which directly limits how much can be stolen if credentials are compromised. High-quality logging and consistent access patterns give you the data needed to detect unusual behavior, which turns stealthy theft into visible anomalies. Focusing monitoring on high-value storage areas concentrates attention where it matters most, while canary-style signals and multi-step pattern thinking help you detect exploration and staging early. Centralizing or controlling access paths reduces the number of places attackers can blend in, and it makes baselines clearer. Finally, response readiness ensures that when detection fires, you can act quickly and precisely rather than freezing or overreacting. The overall theme is that storage security is not just a wall. It is a living system that notices when the normal story changes, and it gives you a chance to intervene before the loss becomes irreversible.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.